Hi guys, very good evening. Welcome to Gradeup, India's largest live learning platform. Okay, today we are going to discuss about one of the topic of this 25 most important topics. The today's topic is from the digital logic. So that is from the minimization of logic functions. So this is one of the important topic in digital logic. So out of this most 25 important topics, this is the one of the topic. So I hope you will enjoy the session. And before we start the session, so you try to like the channel and subscribe to this channel. So we are having a lot of videos presenting on the behalf of this gate preparation. So try to make use of this. You can share with your friends. Yes, Sahil, very good evening. So please quickly join and we can start off the session. So this is a 13th session. This series have been continuing for the last 2 weeks. Okay. So now we are going to discuss the minimization of logic functions. So before to discuss this, so let me introduce myself. Yes. Chandana, good evening. Yes. Okay. Now, before we start the session, so let me introduce myself. Myself, Muralikrishna. I am having 20 years of teaching experience, both in the gate teaching and also I worked in different engineering colleges. And I am topper in one of the NPTEL course that is in the subject Theory of Computation. And I stood top in the exam with 96% of marks. And this has been conducted by IIT Kharagpur in the year 2019. And I am certified as International Engineering Educator through the IZIP certification program and also qualified in the GATE exam, and I have trained more than 50,000 students across the country in different core areas of computer science and engineering. So those are theory of computation, that is a TOC, and operating systems, that is OS, and computer organization and architecture, COA, computer networks, CN, and digital logic design. So these are the 5 areas where I am familiar with. So this is about my brief profile. So please join quickly. Yes, good evening, Paul. Okay. So before we start the session, so let me introduce some of the courses we are offering here at Gradeup and also the faculty available for teaching the computer science. So I'll just concentrate on the explanation about the computer science faculty we are having at Gradeup right now. Yes, and right now we are offering, just a moment, we are offering 3 courses for the computer science in the GATE examination. So GATE computer science, Gear Up is there, Rank Up is there, and Vision course is there. Gear Up 2021, that is targeted for coming GATE exam, 2021 GATE exam. Rank Up is also for short term, that is a 2021 GATE exam, and Vision course is for 2022 GATE. Okay. So yes, Lalit Kumar, good evening. So meanwhile, you can share this channel and you can subscribe to this channel and you can share with your friends, and you can also like the channel if you are really liking it. So more than 3 lakhs subscribers are there for us on the GATE YouTube channel for the Gradeup. And in the Gear Up course, basically it's a concept building program. So we are having 300 plus hours of live classes we are offering, and 3000 plus practice questions and 40 plus mock tests and 75 plus chapter wise study notes we are offering right now. And this is basically ideal for the students who wanted to revise the entire GATE syllabus and wanted to learn the basics from the fundamentals. And Rank Up program is basically score improvement program. The more emphasis on problem solving, it is ideal for the repeaters who wanted to repeat the entire course so that they wanted to get a good score than the previous score. Okay. So we are offering same set of the hours, but emphasis on more on problem solving. So 300 plus hours of live classes and 3000 plus practice questions and 40 plus mock tests and 75 plus chapter wise study notes we are offering right now. And Vision 2022, it is basically, it is a year-long program. It is targeted for 2nd and 3rd year students. The GATE preparation is ideal starting from the 2nd year. So all the core subjects will start from the 2nd year onwards. So better you join from the 2nd year and 3rd year so that you can attempt twice at 3rd year once and also 4th year once to improve it. And right now we are offering nearly 600 plus hours of live classes, 550 plus hours, and 5000 plus practice questions, and 100 plus mock tests, 100 plus chapter wise study notes we are offering. So this is ideal for the students who are in second year and third years, but anybody can join any of the course. There is no restriction on the courses. Okay, so this is ideal conditions I am telling. Once if you are prepared for the GATE exam, it is useful for cracking the exam of ISRO, BARC, NILIT and the DRDO. These four are conducting the examination separately right now. But all other PSUs like Maharatna and Navaratna companies, so they are recruiting the candidates through the GATE score only. So in computer science, the number of PSUs are got increased, and most of the PSUs are recruiting the computer science graduate also based on the GATE score. Okay, so taking the coaching for GATE, it's a multi-purpose. One is for the PSUs, reputed PSUs, and also premier institutions in India. You can get admission into MTech, PhD and other courses. Okay, so all private universities, premier, and IITs, IISc, all these offering the MTech and advanced courses and the PG programs. So GATE score is a mandatory for it. Okay, so that's all about the courses we are offering. If you have any doubts, you can reach us at 965005290 And if you go through the Gradeup Super subscription, so you can get all the structured live courses and you can get the mock test also under the green card. Okay, so that's all about for the courses. Now the faculty. So we are having 4 faculty members right now. One is myself. Already I have introduced about myself. I am having 20 plus years of teaching experience. And other faculty, Satyanarayana Sir is having 13 plus years of teaching experience, and Ankit Doila Sir is having 8 plus years of teaching experience, and Navanit Gupta Sir is having 7 plus years of teaching experience. So these 4 faculty members are right now teaching for the courses. Okay, you can interact with these faculty members when you join any of the courses, either Gear Up right now going on, Gear Up courses, Rank Up course and Vision course. Please hurry up to join because there is a limited time for 2021 GATE. And already a schedule also has been released, that is in the month of February, right? I hope every one of you got this schedule also. There were 2 sessions on one day. I think it is in the month of February. Okay, so that's all about the faculty. Now let us start the session. So meanwhile, you can just share the channel with your friends. You can subscribe to this channel of YouTube, Gradeup's GATE YouTube channel. So we are having more than 3 lakh subscribers right now. So we are offering different YouTube videos on the GATE preparation. Okay, 25 most important topics right now going on. So try to make use of it. Share with your friends. Like it. Yes. Fine. Now KMAP simplification. So basically KMAP simplification is a minimization technique. Okay, how to minimize the logic function. So in order to reduce the number of logic gates required for making a circuit. Okay, KMAP is nothing but Karnaugh map. Okay, so basically KMAP is like a matrix. It consists of rows and columns. So that represents the output values of a Boolean function. Say for example, you are taking a Boolean function of 2 variables or 3 variables or 4 variables. Okay, like f of xy is a Boolean function of 2 variables, or f of xyz is a Boolean function of 3 variables. Okay, so we have to represent all combinations of possible values of the minterms and what they are producing, whether they are producing output 1 or whether they are producing output 0, we have to represent, and based on the output they are producing, we are supposed to minimize using the KMAP method. Okay, so don't leave the session in the middle. I request every one of you, please stay in the session. So a lot of examples I am going to give for more practice for easy understanding of KMAP. So readily solved examples I am going to present. Okay, so this is very important topic. There is no question paper without having a question on the minimization. So either 1 mark question or 2 mark question is mandatory every GATE exam. You can observe, you take any of the GATE paper computer science, so very easy question will come on the minimization of logic functions. Okay, so try to make use of this session. Okay, and try to score that 1 or 2 marks on this particular topic. I am sure if you attend this topic till the end, you will get you will score that mark. Okay, The output values placed in each cell are derived from the min term of the Boolean function. So min term is nothing but it's a product term. Okay, for example, x and y are the two variables, for example. So the values of x, y can be 0, 0, 0, 1, 1, 0, 1, 1. So these are the four min terms. So that is nothing but x bar, y bar, and x bar, y, x, y bar, and x, y. So these are the four min terms for two variables. So if you take a 3 variables, you can have 2 power 3 min terms, that is a 8 min terms. Okay. So basically a min term is a product term that contains all of the function variables exactly once, either complemented or in a non-complemented form. Either complemented or non-complemented form. So that is nothing but x bar is a complemented, x is a non-complemented form. So this is how we are going to represent, as I told you. So if we take a 3 Boolean variables, 2 power 3 combinations, we will represent. So everything diagrammatically I will show you. So please listen and observe carefully. Okay. Now coming to the one example, 2 Boolean variables if we take, for example. So 2 Boolean variables, as I told you, so we are having 4 min terms, x bar, y bar, x bar, y, x, y bar, and x, y. So x value, y value 0 indicates x bar, y bar. X value 0, y value 1 indicates it's x bar, y. X value 1 and y value 0 indicates x, y bar. So 0 is a primed. Yes, Abhishek Naik, good evening. Very happy to see you. Okay. So meanwhile, what you people can do, you can share the channel, you can subscribe the channel, and also you can like the channel if you are really liking it. So more than 3 lakh subscribers are there right now for the Gradeup only for Gate channel. Okay, fine. Okay, now let us suppose you are taking these 2 variable min terms. How I can represent in the form of matrix? So there can be different types of Boolean functions. So here this is one Boolean function where f of x comma y is equal to xy. Xy means only xy term is producing 1, remaining all terms are producing 0. So this is one function. Other function is f of xy is equal to x plus y. So either x is 1 or y is 1, output is 1. So 3 min terms are producing 1s, only 1 min term producing 0. So how we can represent those things in the map? So that is what first representation. So we can for 2 variables 4 squares will come. So this is indicating 0, 0, 0, 0, 0, 1. So this is indicating 0, 0. This is indicating 0, 1. This is indicating 1, 0. This is indicating 1, 1. So 1, 1 term it is producing 1. So that's why we have kept 1 here. Remaining all are zeros here. For example, for this function, if you take f of x plus y, that is f of x comma y is equal to x plus y. Here 3 min terms are producing 1s, 0, 1, 1, 0, 1, 1. So 0, 1. So this is the 4 squares of 2 variables. So this is 0, 0, 0, 1, 1, 0, 1, 1. Adjacent squares to be differed by only 1 bit, we have to use the gray code representation for this. So these are the min terms that are producing 1 and only 1 min term producing 0. So in a 2 variable min term, if you take this one for example, okay, so this will come under the area x. So last row comes under area x, first row comes under area x bar, okay, and first column comes under area y bar where y value is 0, second column comes under y where y value is 1, okay. Similarly here also 2 variables, okay, x bar area, these two comes under x bar area, these two comes under x area, these two comes under y bar area, these two comes under y area. I am not plotting them, just I am telling you the areas where you have to plot in the KMAP, because adjacent ones to be plotted and we have to form the pairs and quad or octet and then minimize the logic function. So this is a 2 variable Boolean function, 2 Boolean variables x and y. I have shown you how we have to represent the KMAP for the 2 variables, and as an example I have shown you f of xy is equal to xy, that is one function, that is AND operation, x plus y is a OR operation, okay. So this is how we have to represent the 2 variables. Now coming to the 3 variable Boolean function, you can just see this. So 3 variable Boolean function, how it is represented, you could check. So what are the 3 variables here? X, y and z, okay. So the combinations, how many combinations will come for the 3 variables? How many combinations? 2 power 3 combinations. For a 3 Boolean variables, we are having 2 power 3 combinations. So 2 power 3 is nothing but 8 combinations will come. Is it clear? Yes. Shubham, good evening. Are you able to follow? Okay. And is my voice clear? Some of you please indicate. Please respond here. Shubham or Lalit, is my voice and everything is fine? Is it clear? Please respond. And meanwhile, if you have any doubt also you could ask. And even after this is over, after the session is over, in the comment box you can continue your comments on the 4 variable map or 3 variable map on problems you solved, so that I will respond to your queries even after the session is over. Okay. So I hope every one of you will continue asking the questions, and I will respond on each and every question on the comment box. So for example, if we take a 3 variables, so yes, so thank you Chandana. Okay, fine. We are having x value 0, y value 0, z value 0, that is indicating x bar, y bar, z bar. And similarly 0 0 1, so this is x bar, y bar, z, and 0 1 0 x bar, y, z bar. Okay, like that we are having 8 combinations. So 8 combinations of minterms. So using the 3 variables we can have 8 combinations of minterms, right? So we can represent in the form of a KMAP like this. You can see the KMAP representation for the 3 variables. This is the KMAP representation for the 3 variables. So we are having 0 0 0, 0 0 1, 0 1 1 and 0 1 0. And meanwhile, if you have any doubt you could ask. If you have any doubt you could ask. And for 8 minterms we are having 8 squares are provided here. I just shown you what are the minterms here. 0 0 0, x bar, y bar, z bar. So this is one minterm, x bar, y bar, z. And the code we are using is a gray code actually. Okay, so this is 0 0 0 1 1 0 1 1. So gray code is nothing but the adjacent squares are differed by only one bit. For instance, if I take this square and this square for example, so 0 0 1 is this, okay, and 0 1 1 is this. So if you see the 3 bits, okay, first bit is as it is, last bit is as it is, only the second bit is modified. So that means 0 as 1. So difference is exactly 1 bit for the adjacent squares. The difference is only 1 bit. So remaining all will be as it is. Okay. So that's what we have to follow the gray code representation. Normally normal code is we write like 0 0 0 1 1 0 1 1. Gray code is 0 0 0 1 1 0 1 1. So adjacency is preserved here. Okay. I think that basic thing you already know about this adjacency. Yes, differed by only 1 bit. Exactly. Okay. So now these things, for example, the areas if we take, let us suppose. So areas is nothing but where the x is present, where the y is present, where the z is present, we have to plot them. For example, if x value is high, for example, this entire row, this entire last row, x value 1, so this area comes under the x, and this entire row, first row where the x value present is 0. Okay, so that entire 4 squares comes under x bar area. That 4 squares comes under x bar area. Okay, and coming to y and z values, where y is 1. If you take the third column and fourth column together, so this one, the third column and fourth column together, where y value is 1, so we can plot them as a y area. And z area means where z is 1. If you take the second column and the third column, so where the z value is high, so that we can plot it as z. Similarly, what is the y bar area? First column and second column if we take, okay, so y value 0 in both the cases. So z bar z is cancelled, so this is a y bar area. Similarly, first column and the last column comes under z bar area. First column 2 squares and last column 2 squares comes under z bar area. Yes. Hi. Jai. Okay. Fine. So this is what the areas we have to take in the 3 variable map. And this example if we take, what happens is, x bar y bar z, x bar yz, x y bar z, x y z. So these are the terms producing 1. So this is x bar y bar z. This one is producing x bar y bar z. I am just separating the squares here. Okay, I hope you are following. Is it clear? What will, if a function is sum of all min terms, so that is table contains all ones, then what will happen? Yes, very good question, Sahil. So if all are ones, for example, then directly the function will be 1. So f of xyz is equal to 1. So whatever the min term that is producing 1, so directly that function is represented as f of xyz is equal to 1, that's all. So 1 is output, that's all. Okay. So now these are the terms. Actually x bar y bar z bar, x bar y bar z, so this is the x bar y bar z. Okay, and x bar yz, so this is the one which is representing x bar yz, and this is the one representing x y bar z. The fourth one I have mentioned here. Okay, and x y z, so this is the one which is representing x y z. Yes, free of all variables. Yes, Chandana, correct. Okay. So now these ones are actually adjacent. I am not plotting these ones, just I am telling you the positions. For example, if these min terms only producing 1, something like x bar y bar z, so this is producing 1, x bar y bar z is producing 1, x bar yz is producing 1, x bar yz, so this term is also producing 1, and x y bar z, this term is also producing 1, 1 0 1. Okay, and x y z, so this term also producing 1. It means that remaining all terms are producing 0. Okay, so as Sahil said, if every function is producing 1, it is independent of all the variables, so it is output should be 1. Yes. Okay, so this is how we are going to represent, and I request every one of you to don't leave the session. You stay in the session till the end, so that you will get maximum out of this, whatever is best possible, because it is a 50-minute session only. As much as possible you try to grasp the subject in this 50 minutes duration. You will try to learn the KMAP. Okay, now coming to the next. This is another example. So I brought a lot of these examples here. Let us suppose I am having a KMAP like this. F of xyz is 0 0 0, 0 0 1 is producing, 0 1 1 is producing 1, 0 1 0 producing 1, 1 0 0 and 1 1 0. So these are 1 2 3 4 5 6 min terms are producing ones. So we have to plot the adjacent ones in fact here. So as much as possible, maximum number of adjacent ones should be covered. Okay, for example, if you take this one, these two, let us suppose this and this, these are adjacent, but one is 1, one is 0, we can't plot them. So different colors I have shown. So the 4 ones here plotted actually. This is called a quad. These are all adjacent. So these 4 ones comes under which area? X bar area. So it is coming under x bar area. The function is minimized as x bar plus, okay, and leftmost 2 ones, rightmost 2 ones, these are adjacent. So in order to cover the remaining 2 ones actually, so maximum possible ones can be covered, something like this. So these 2 ones and these 2 ones are adjacent. So this comes under which area? X bar x is cancelled. Here y bar z bar, y z bar. So y bar y cancel, it is comes under z bar area. So first column, last column comes under z bar area. So this is x bar plus z bar. You see the bigger function, it has been minimized to very small function. So it is independent of y. So it is dependent on x and z. Are you following? Is it clear? So this is x bar plus z bar. X bar plus z bar. No. X bar plus z bar. Electrobot. That is a mistake actually. Please try to correct this. Is it clear? Are you following? And if you have any doubt, you can just ping me your doubt and I will solve your doubt. Okay, fine. Thank you. And now coming to the next example. So the minimized function here is x bar plus z bar. Yes, Sahil. Yeah, thank you Sahil for your response. And I request every one of you not to leave the session. Please stay in the session till the end so that more examples you can solve. Now, 4 variable KMAP. So we are having 4 variables. So that is W, X, Y and Z. W, X, Y and Z. 4 variables are there. So these are all actually the places of minterms I have just mentioned for better understanding. And here also we have followed the gray code representation, reflected code representation. So 4 minterms are producing how many combinations? 2 power 4 combinations. What are the 2 power 4 combinations? 16 combinations. So starting from 0, 0, 0, 0, 0, 0, 0, 1 and so on 1, 1, 1, 1. So total 16 combinations are there. So this is 0, 0, 0, 1, 1, 0, 1, 1. If you see the areas, so when you are plotting the minimized equation to obtain, so areas we have to decide. Okay. So what is the x area where x is 1? So if you take the last two rows, so actually 4 rows, 4 columns are there in this matrix, right? In this KMAP. Last 2 columns, all the 8 squares comes under the area W, where W is 1. Okay, and x value, where x is 1. So second row and third row comes under the area x, where x value is 1 in both the places. Okay, now what is the x bar area and w bar area? The first column and the second column comes under w bar, where w is 0 and x bar x cancel. Okay, so when you decide the areas like this, very easy to plot the squares and find out the minimized expression, either in sum of products form or in product of sums form. There are 2 ways of doing this. I will tell you how to find out SOP form and also POS form. Understand? Okay. Now coming to the upper area. So like what is the y area here, where y is high? So I am talking about the columns now. Third column and fourth column. If you take a third column and fourth column where 1, 1 and 1, 0 present, so y value is 1. So this is comes under area y. Okay. Area y. What is the z area? Second column and third column where the z is high. Second and third columns comes under the area z. And where is y bar area? First column and second column comes under y bar area. Y bar area. Where is the z bar area? First column and the last column, fourth column. These two comes under z bar only. These two together is coming under z bar. So this is the how we are going to represent the areas of each variable out of these 4 variables in the 4 variable KMAP. So 4 cross 4, 2 power 4, 16 combination of minterms you will get. But for some functions, all minterms may not produce ones. Some minterms may be producing zeros, some minterms may be producing ones. Okay. So based on the ones they are producing, so we have to minimize the expression. Okay. So I hope you are following, every one of you are following. Is it clear? So if you have any doubt, not only now, even after the class is over, you can just ping me in the chat box, later in the comment box. I will try to answer each one of your question. Okay. Is it clear? Please respond, some of you. I hope every one of you are following, and I will give you a lot of other examples also. So we'll try to get it out of maximum subject you can get. Now here there is another example. This is a 4 variable KMAP. This is a 4 variable KMAP. I am just dividing them. Yes. Yes. Thank you, Sahil. Harshali, thank you. Okay, fine. Now coming to this this one. So how to get the minimized equation for this? Yes, Pandey, Yash Kumar Pandey, or anybody else, you can just give an answer to this. You can just give an answer to this. I am just plotting like this. Already plotting is also given. Green color are 4 corner ones. 4 corner ones are adjacent. 4 corner ones are adjacent. Okay. And top 2 ones, light pink color. Okay. Top 2 ones, bottom 2 ones. Okay. So that is one quad. And these 2 ones, actually this is the only one. So this is adjacent to this, that has been combined. That has been combined. So that if you take the function, minimized function, actually when you are plotting ones, you will get in sum of products form. Sum of products form. Okay. So what are the last 4 ones? That is the corner ones. What kind of classes are available in conjunctive normal form? Can explain the meaning. What kind of classes are available? Conjunctive normal form. No. This is in which subject you are asking, Chandana? So we are talking about the minimization of logic function here. Okay. Sum of products form and product of sums form only we will get here. Okay. Now coming to this 4 corner ones. 4 corner ones comes under. So this one and this one actually. This is coming under x bar area as far as this wx is concerned. And yz is concerned, that will come under z bar area. So x bar z bar, f is equal to x bar z bar. Okay. Now if you take the top 2 ones and bottom 2 ones, so it comes under x bar in the case of the rows, and in the case of the columns it comes under y bar. So this is x bar y bar, the second quad. And the third one, so if you take a last this one, so this is coming under w bar area, here yz bar area. So this is another product term. So that is a w bar yz bar. 2 ones, this 2 ones pair comes under w bar yz bar, and 4 corner ones comes under x bar z bar, and top 2 ones, bottom 2 ones comes under x bar y bar. So this is the minimized sum of products form. SOP is nothing but sum of products form. Sum of products form. Sum of products form. If you wanted to get in product of sums form, okay, so if you wanted to get in product of sums form, we are supposed to plot the zeros. I will tell you one more example for that. Okay, so now let us go for another example. Okay, I hope you are following. So this is, there are sometimes now multiple expressions also will come out. Okay, sometimes multiple expressions also will come out. This is one example for that. So 2 4 variable KMAPs I have shown side by side here. Okay, so there is a possibility of getting multiple results. So these are the minterms producing ones. So here, if you take this one, this is combined along with this adjacent one, or it can be combined with this one also. But the number of literals you will be getting is same, but the function will be different. But output will be the number of literals remains same. The number of literals will be remain same. Yes. Okay. So let us suppose if we take this one for example, the first column comes under the function f is equal to y bar z bar. This is come under y bar z bar, and these 2 ones comes under w bar yz, w bar yz, and these 2 comes under w bar xy, w bar xy. So this is the minimized. So number of letters are 1, 2, 3, 4, 5, 6, 7, 8. 8 literals are there. Okay. Now this one, second one. I think Chandana was asking like what kind of clauses are available in conjunctive normal form. So are you talking about the same subject or a different subject? Please let me know, Chandana. Okay. So now here these are the terms, and differently I could do here. So there is another form, because adjacency can be done in multiple ways. Yes, multiple ways. So now here in this connection, the output function for the second diagram, so this is y bar z bar, and this remains same only, so that is w bar yz plus this remains in w bar x z bar, that's all. Okay, so this is the function. Okay, na? So that means the number of literals in both the cases is same, and the minimization and number of gates required for both the functions will be same, but output may be different. So multiple outputs are also possible in some cases. So this is the best example to say that this one has can be combined with this adjacent, or this also is an adjacent for this one. Okay, now coming to the next. Okay, so now a lot of examples on a single page I have brought for you to understand better. So please have a look at all these things. I'll just remove my image for a while. Yes. So this is the best one to understand. There are 8 examples on a 3 variable map, and I took 8 examples on a 4 variable map. It is readily available so that we can get through this. Okay. So now f of sigma of 0 comma 4 is b bar c bar. So b bar c bar. So what is the b bar c bar? Actually these two ones are combined like this. I am just showing with a red color. So these two are adjacent. So a bar a cancel. So this comes under b bar c bar. So this is b bar c bar. So if two ones are like this, we can combine this as a pair. So this comes under, this is a and this is b bar. So in the row it comes under a, in the column it comes under b bar. So this is a b bar, and these 4 ones are also adjacent. So number of ones what you are combining, you can combine number of ones as powers of 2, either single one, if it is only one present, there is no other adjacent ones, single one you can take it as a pair, and 2 ones you can take it as a pair, and 4 ones you can take, 8 ones you can take, 16 ones you can take. You cannot take 3 ones, you cannot take 5 ones. Number of ones you are combining is to be adjacent, and powers of 2. It should be powers of 2. And these 4 ones are under single quad producing. So this is a bar a cancel. So this will come under this area. So this area comes means it's a b bar. Okay. Now these 4 ones are adjacent. So in this we can take a bar. So this is under the area of a bar, because all these will be cancelled. B bar, C bar, B bar, C, BC, and comes under 1. Okay. Now coming to this fifth one, you can see here. So what is this? These 2 ones are combined. What is the area of this? This comes under, here it is a bar, here it is C. So a bar C. So this is a bar C. This is only a bar. And what about this? These 2 ones are adjacent. 2 corner ones is combined as adjacent. So this comes under a C bar. And these 2 ones are also adjacent. So this is coming under what? A bar C bar. This is a bar C bar. And these 4 ones are adjacent. So quad. So this is a bar a cancel. This is C bar. This is coming under C bar. These are the 3 variable maps. Okay. So now, yes, exactly. Sheikh Umar, you are right. Now coming to the next 4 variable maps. Okay, so here only 2 ones are present. So these 2 are combined. So this is, first of all, we are having, this is under B bar area. So B bar, C bar, D bar. So this is a B bar, C bar, D bar. Okay. Now only these 2 ones are min terms 1, remaining all are zeros. So this is coming under B, and here it is coming under C bar D. So this is B C bar D. And the third one, if you see, okay, what is the third one? 2 ones are combined here. So this is AB, and this comes under D. So this is ABD. ABD. And coming to this one and this one is adjacent. So this is A bar B, and these 2 comes under D bar. A bar B, D bar. And coming to this, these 4 ones are adjacent. So this comes under here, it is under A bar, and here it is under C. So this is A bar C. So A bar C is answer for the fifth one. Okay. Now coming to this, these two ones are adjacent. Yes. So what is the value of this? So this is B D bar, and these two ones and bottom two ones are also adjacent. We can combine like this. So why these many examples? Because what are the possibilities of adjacency you can understand. That's the reason I brought more examples here. So in the rows it is comes under B bar. Okay, in the columns it is coming under C. So B bar C. And here 4 corner ones can be combined as a one quad. So 4 corner ones coming under in the rows it is coming under B bar, in the columns it is coming under D bar. So this is B bar D bar. Like that we can simplify the Boolean expression. Okay, and some more examples also I will tell you. Please watch, don't leave the session, and I am about to close the session within a 5 to 10 minutes. Please watch it. Okay, so for example, if I wanted to simplify this is another example. So these two ones you can plot, okay, because 3 ones I can't combine, and these two ones you can plot, these two ones you can plot. Okay, so what is the value of this? The value of this is coming under C, right? So the value of the first pair is C bar D A. This is coming under the area A, and this is middle ones, two ones. So this is C D B, and the last two ones it is C D bar A bar, C D bar A bar. That's all. So there are 9 literals in this minimized expression. Like this we can do. And sometimes now product of sums they used to ask. How to get product of sums? So this is a sum of products. Here itself I will explain a product of sums for the same. Let us suppose if I am having remaining all terms will be 0. Remaining all terms will be 0. So when you plot the zeros, you will get the product of sums. When you plot the zeros, you will get the product of sums. Listen carefully, all of you, every one of you. This is an important example. For example, if you wanted to plot the zeros, just like how you are plotting ones, in a similar way zeros can be plotted. Okay, so these 4 zeros is adjacent. I can plot them. So instead of plotting only 2 zeros, I can combine along with another 2 which are adjacent. So this is 1. And 4 corner zeros not possible because there is a corner 1 here. Okay, so to cover these zeros, what we can do is these 2 zeros can be combined with these 2 zeros, and this is not required. The first row is not required now because anyway it is covered. Okay, now coming to this 0. Okay, this 0 can be combined with either this or this, So let us combine with, anyway this is uncovered now, so if you cover with this it is fine, and this is not required now. First column what I have done is not required. Okay, now these 4 zeros comes under, when the zeros are plotted you will get f dash. So f dash is equal to this is C bar A bar plus, and these top 2 ones, bottom 2 ones comes under D bar A, this one and this one. So this is D bar A. Okay, and these 2 zeros comes under CD B bar. So this is the F bar. So when F bar is there, for example, in sum of products form, F will be in product of sums. So F will be again, if you complement this, it will be like C bar A bar whole bar. Okay, so that is a C plus A into, it will become D plus A bar into C bar plus D bar plus B. So this is a product of sums form. If don't cares are there, we can use the don't care as either 0 or 1. X is nothing but don't care. It can be taken as 0 or 1. Yes, Sahil, that also I will tell you. Number of prime implicants also I will tell you. First of all, you see the minimization first. So this example if we take, okay, I can take the 4 corner ones as one this thing. 4 corner ones is 1 quad. Okay, to cover this one, I can take these two ones and these two ones as adjacent, and we can take these two ones and these two ones. So that is a minimal sum. So what is the minimal sum here? F is equal to 4 corner ones comes under D bar B bar. D bar B bar. Yes. Yes, exactly. Prime implicants I will tell you. Please wait. First let me give the sum of products form. So D bar B bar 4 corner ones, and top two ones bottom two ones comes under D bar A. D bar A. Okay. Now what is to be taken now? These two comes under CDB. CDB plus, and this one comes under C bar D A bar. C bar D A bar. So these are the this is the minimal sum of products form. Okay. Yes, good evening, Dilip and Himani Bharadwaj, good evening. So prime implicants, when you are finding, it's very simple. In addition to this, we can also plot something. Listen, these two ones are adjacent now, we can plot them. It is also one prime implicant. These two are adjacent, this is also comes under prime implicant. So number of prime implicants are 4 corner ones is 1 prime implicant. So all whatever you have plotted are prime implicant and 2 additional. So the total prime implicants are 5. Yes, Chandana, you are correct. And essential prime implicant distinguished ones. So this is a distinguished one, this is a distinguished one, and this is a distinguished one. That means a prime implicant which contains one or more distinguished ones is nothing but essential prime implicant. So there are 2 prime implicants containing distinguished ones. 4 corner ones is a essential prime implicant, and this one is also essential prime implicant because it contains at least one distinguished one. So 2 essential prime implicants. Okay, now coming to the next, let us make it fast. And yes, here we can combine these 4 ones, or else we can do one thing. As far as the minimization is concerned, just I am talking about minimization first. As far as the minimization is concerned, okay, these 4 ones if we combine, and these two ones can be taken as a adjacent, and this can be taken as adjacent. That's all. Only 3 terms we can take in minimization. And as far as the prime implicants are concerned, this is also will come under the prime implicant. Okay, and these 4 ones also comes under one more prime implicant, like this. So number of prime implicants are 1, 2, 3, 4, 5. Still any more? So minimal sum of products SOP form. SOP form is I am taking the 4 corner ones, this one. So this comes under A bar D. So A bar D plus, and these 4 corner ones 2. So that is coming under, it is a B D bar. B D bar is one thing, plus A bar D plus these 4 corner one B D bar, and these third column comes under C D. Actually these are the 3 terms. In addition to that, these also combined and this is also combined. Total 5 prime implicants we got. Anything else? Not possible. So prime implicants are 5, and essential. So this is one distinguished one, this is one distinguished one, and this is also distinguished one. Okay, and that's all. 3 distinguished ones. So 3 distinguished one means 3 essential prime implicants. 5 and 3 exactly. Can you please explain when we have to add non-essential prime implicants in minimized? Actually, if every prime implicant is essential prime implicant, so minimized sum of products form contains all the essential prime implicants. Minimized sum of products form contains all the essential prime implicants. Okay. If all prime implicants are essential prime implicant, so all will be combined here. So yes, Pi is equal to 5 and EPI is equal to 3. Correct. I hope you understood, Sahil. Okay, now coming to this one more example. So we are having 8 ones we can combine. Okay, and to cover these two ones, I can take these two ones as adjacent. I am talking about minimal sum of products form. So here like this. So this 4 ones, 8 ones comes under only D. So SOP is equal to D first. SOP is equal to D plus these two corner ones comes under CB bar plus, and top 4 ones comes under C bar B. That's all. This is sum of products form. For example, product of sums, if you want, same thing. So I will tell you that also. POS form is we have to plot the zeros. So this 0 is adjacent, and these two zeros are adjacent here. So this comes under, so now POS we have to find out, no? So for a POS, first F dash you will get when zeros are plotted. So F dash is like C bar D bar B bar plus last two zeros C D bar B. So this is F bar, but F will be in product of sums. So this will become C plus D plus B. You have to complement it into C bar plus D plus B bar. That's all. This is a product of two sums. I hope you have understood this. Okay. Now coming to this one, that's all. These are the things we are going to solve, right? I hope every one of you understood and enjoyed the session. Before concluding the session, so a small announcement regarding our achievers. Okay, so 60 plus Gradeup students are in top 100 in the year 2020 GATE exam. We got 4th rank in computer science, 20th rank. There are 2 people got All India 39th rank and 47th rank, and we are having All India topper in engineering services exam under the ECE, Electronics and Telecommunication Engineering. And in 2019, 2 mechanical students secured All India 10th rank and 27th rank respectively. So big congratulations to all these achievers. Total 60 plus Gradeup students are in top 100. I wish every one of you being in the top list for the coming sessions, for the coming 2021. Okay, and this digital session will be there on the next Sunday also. So try to, there are the 3 sessions. The next session would be on the combinational logic circuits. Okay, next number system, all those things. Okay, so these are combinational sequential is one session, and number system representation, fixed and floating point, one session we are going to conduct. Try to attend all the classes. Okay, and you continue giving these questions in the chat box, that is in the comment box, so that I will try to answer those, and keep sharing these sessions with your friends. And before concluding the session, I will tell you what is the Gradeup Super. Gradeup Super is a one-stop solution for all your preparation needs. Once if you are getting subscription to this Gradeup Super, you can get all structured live courses and India's best faculty access you can have, and also complete doubt resolution will be there instantaneously. Full syllabus coverage for your exam, and also under the green card you will get on online mock test you will get, and designed by these mock tests are being designed by the toppers, and based on the latest pattern of examination the question papers are designed. You try to get a full advantage of this Gradeup Super. You can go to the Play Store and download the Gradeup app and follow the Gradeup this super subscription. Okay, so now offers are being going on. Try to get as early as possible, and try to share with your friends and subscribe to the YouTube channel for getting a more benefit. So thank you so much. Before concluding the session, you can also reach us at 96500529004, or you can mail us at help@gradeup.co, so that all your queries will be answered. So this is all about for today's session. So we have discussed about minimization of logic functions using KMAP, and also I told you SOP and POS and prime implicants, essential prime implicants, very brief number of examples. Because of we are having only 1 hour session today, and I will try to conduct some marathon sessions before the exam in future. Okay, so thank you so much. Thank you one and all. I wish you every one of you good luck, and thank you very much. Go Gradeup, prepare smart, score better, and stay safe. Thank you one and all. Have a good night.